All right, guys, second and last video here for you guys. So today, or this one, I want to talk about compound sentences that have the word and in between the two parts of the compound sentence and not the word or. So let's start out by looking at how these are going to be a little bit different than what the other ones looked at. So what if I want you to do x is less than 5 and x is greater than -1. If I'm going to graph this, here's 0, here's -1, -2, 1, 2, 3, 4, 5. Here's 5. Okay, so this says I want all the numbers that are less than 5. So that would be everything this way. This set is all the numbers greater than -1, so that would be that way. Now the thing is, the word in between these is the word and, which means that's not my final answer. My final answer is just those numbers that are in this graph and that graph. So normally when I was in class, I asked the kids, name a number that's in both the top set and the bottom set, because remember, the key word here is both. And they would say, one of the kids said, I used the same example, and he said 1. And I said, I agree, because I can see that the number 1 here is in this set and that set. So that's a number that's, in both of them. And in fact, the kids could figure out that it would be all the numbers between -1 and 5. So my final answer is really just going to be the numbers between -1 and 5. Is that okay? Let's do another one. Let's do, okay, come on. What's going on? There we go. Okay, let's do x is less than or equal to 3 and x is greater than 0. So we'll draw a number line. Here we go. Move this down a little bit. Okay, 0, 1, 2, 3, 4, 5, -1, -2. Okay, so we want the numbers less than or equal to 3. That's all of those. And we want the numbers greater than 0. So that's all of those. But because it's the word and in between, I only want the numbers that are in both this set and that set. And I think you can tell it's where they overlap. So that would be everything from here to there. And this is open because this is open here, which means 0 is not included in that top set. So it can't be included in the and. Okay? I hope you're getting the hang of that. Okay, so now, what are we going to do? What is an inequality? What's a compound sentence going to look like? Well, let's try this one. 2x minus 3 is greater than 1. 10 minus 2x is greater than 0. And we're going to connect these with the word and. So this is going to be a little different than the or now. Now, just like with the ors, we're going to go ahead and we're going to solve these individually. So I'm going to solve this. I'm going to add 3 to both sides, or move the -3 over where it becomes positive. Then I'm going to divide by 2, and I'm going to get x is greater than 2. I did not switch my inequality because I didn't divide by a negative. Over here, I'm going to subtract 10 So I'll have negative 2x is greater than negative 10. Now here, I'm going to divide by negative 2. So I'm going to have to switch my inequality. Negative divided by a negative is a positive. Now remember now here though, this is a connector by the word and. So I'm going to draw my number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we go. So this set is everything greater than 2. This one is everything less than 5. But when I'm asking you to solve the compound sentence, I am asking you to give me your final answer is only those numbers that solve this and that one. So anything here solves this one. Anything here solves that one. Where are the numbers that solve both of those inequalities? Remember, the word and implies it must do both. So that's going to be just the numbers where they overlap from 2 to 5. So if you're going to do this on your paper, then I'd like you to put your final answer in a different color when you do your homework. Okay, so one more thing. I'm trying to not make this too long because I know you can only watch videos for so long. So now here's another one I want to do with you guys. What if we have this? Here's my and. All right. So I don't know if you'd notice this. I asked this in class, and usually there was at least one person that noticed that in these two inequalities, this expression is the same in this one. Unlike up here, this was 2x minus 3, that was 10 minus 2x. Those weren't the same. But down here, these are the same. But I'm still going to do this, well, I'm not going to do this the same way. So mathematicians don't really like to write. So if they had this situation, because this expression's the same, they would write this like this. Now, watch carefully here. This, half of this, is just this, isn't it? And this half of it, overlapping, is just this, which has been flipped around. Because when mathematicians write a double inequality like this, these signs always want to be pointing the same way. That's why they flip that around, okay? So basically what they did is put two inequalities in one. Anytime you see this, you can only do this with an and statement. It has to be an and. Okay, now, why do mathematicians do this? Just to give you guys something else you gotta learn. No, that's not why. It's because they really don't like writing, and mathematicians are trying to be very efficient. And they said, you know what? We can solve this faster if we put it in this form and we solve them basically both at once. So if I covered this up and said to you, what would you do first to solve this equation? You would probably all tell me, well, I'd add 3 to both sides of that inequality, right? And if this wasn't here, this part over here, let me cover it up. If this part wasn't here, what would you do first to solve this inequality? You would add 3 to both sides, okay? So what we're gonna do is we're just gonna add 3 to all 3 parts, and we're actually solving the two inequalities at the same time. So I add 3, those are gonna go away, and I'm gonna get 2x is less than 10 and is greater than 2. Now, again, if this wasn't here, wouldn't you divide both sides of that by 2? And if this wasn't here, you would divide both of these sides by 2. So I'm just going to divide all the parts by 2. That is going to give me my final answer of x, those cancel out, is less than 5 and greater than 1. Okay, now, how do we graph this? Well, the proper way, you can read this two ways. Some kids read it, 1 is less than x and x is less than 5. I prefer to read it, x is greater than 1 and x is less than 5. So let's see what this looks like graphed. Here's 5, 4, 3, 2, 1, 0, -1, etc. All right, so if I were just graphing this half, it says x is less than 5. So that's all of that. Do we agree? And if I was graphing this half, now you got to be careful. It doesn't say x is less than 1. It says 1 is less than x, or if we read from the x is greater than 1. So that's going to be everything that way. Now remember, this came from an and statement. So now I only want the numbers that are in this set and that set. That is where they overlap, and it's going to be everything between 1 and 5. So this then is my final answer. All the numbers in here, 1, 2, everything between these should make that statement true. Okay? So let's do one of the ones from your homework paper. I'm not sure if you have it handy. So now this should allow you to do this homework paper, which is, oh, wrong one, my bad. Uh-oh, I got my papers messed up here, okay? So this should allow you to do this homework now, which says Algebra 1, Compound Sentences 2. So what I suggest is if you don't have this printed out yet, why don't you pause the video, go print it out, and come back because we're going to do one of these together, okay? All right. So here's the one we're going to do together. Let's do number 8 on the back. Okay, so this is one of those condensed ones where we're going to solve both sides of this at once. So again, if this was not here and you were solving this side, you would add 3 to both parts. And if this side wasn't here and you were solving that inequality, you would add 3 there and you would add 3 there. So I'm just going to do it to all 3 parts at once. So these are going to cancel. Now be careful, I'm left with a negative x. This is going to be 5 and this is going to be -2. Now, I'm not done because I can't leave negative x. So what I'm going to do is I'm going to multiply everything by -1. Now, I'm multiplying by a negative, so ding, 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 red lights flashing. That means this will become positive, this will become negative, this will become positive, but it also means that my signs are going to reverse. All right, so now all I have to do is graph this solution set. So I've got -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Okay, so let's do half at a time. What does this half say? X is greater than or equal to -5. Here's -5. I want greater than or equal to it. Okay? What does this half say? Read from the X. X is less than or equal to 2. That's everything there. Now, because this is an AND statement, we know it's always an AND when it's in that condensed version, I only want the numbers that are in both this set and that set, so it's going to be here to here. Now, here's what I'm going to tell you, because some of you guys, a lot of you guys are all really bright. If you look at this statement here, whoops, that doesn't have the eraser on it. If you look at this statement here, this whole thing, isn't X position between +2 and -5? And isn't that what we've graphed here? The numbers from -5 to +2. Usually the smaller numbers here, but because we switched the sign, it flipped everything around. So if you can go right from this to this without having to do these two graphs, be my guest and go ahead. That's my goal eventually, is that you can do that. Okay? So that was number 8 from your homework. So now you guys should be able to do this worksheet right here, and that's what you got to do. And then I'm going to be sending you an email with all this information, but you'll already know that by the time you see this video. So, all right, guys, thanks for your attention. See ya. Bye.